Hi everyone, welcome back. Today we're going to be looking at standard 7.rp.a.2a. Decide whether two quantities are in a proportional relationship by testing for equivalent ratios in a table or graphing on a coordinate plane and observing whether the graph is a straight line through the origin. Before we get into our lesson on proportional relationships, let's take a review of graphing on the coordinate plane. When we plot points on the grid or the coordinate plane, we start at the origin and move left or right on the x-axis or up or down on the y-axis. So left or right on the x-axis and up or down on the y-axis. Let's now go ahead and attempt plotting these 2 points, 1, 4, 2, 8. So the setup of a point is that we have an x value, which is the first number, and then a y value. So both of these, there's an x and a y. As mentioned before, we're going to start on our x-axis. So we must first go to the number 1 on the x-axis, which would be here. And then we move up 4 on the y-axis. So 1, and then move up 1, 2, 3, 4. That gives us a spot at 1, 4. So we can label this point 1, 4. Now let's take a look at the point 2, 8. So I go to the number 2 on my x-axis, and then I'm going to count up to the number 8 on my y-axis. Let's try a few more. Let's take a look at the number -2, 3. So here the x is negative, so I have to go to the left. These here should be negative, by the way. I go to the left of my x-axis and I find the number -2, and then my positive y values are up. So I go to -2 and then I go up 1, 2, 3 for a location of -2, 3. Now let's take a look at another point where both of our values are negative. Let's try -5, -7. So again, I go on my x-axis and I go to -5, and then I go down, because it's negative, to -7. And that's the point, -5, -7. Now let's try one more. Let's take a look at a point where our x is positive, but our y is negative. Let's go 6, -3. So here we're going to start at +6, and then we're going to go down to -3. And that's our point, +6, -3. This here is quadrant 1. This is quadrant 2, quadrant 3, and then quadrant 4. Our counting for these quadrants, we go counterclockwise. So 1, 2, 3, 4. Now here we have a table. So we're going to sketch the points from this table, and that will help us to determine whether or not the relationship is indeed proportional. So whenever you have a table, you have values of x and values of y, we can rewrite this as a point. And as a point, x would go first. So 0, 0 would be that point. 1, 3 would be the second point. And then 2, 6 would be the third point. Here we have labels, hours and miles, outside of our x and y. If you notice that the axes are already labeled with x and y. So for the x-axis, it's hours. So we're going to just go ahead and write that down here. And for the y-axis, it's miles. Okay, now let's go ahead and plot these points. Starting with the first one, 0, 0, that's right here in the origin. Now 1 on my x-axis, 3 on my y is the point 1, 3. 2 on my x, 6 on my y is my third point. I can now go ahead and connect these points using a line. I'm going to draw as straight as I possibly can. And whenever we draw a line, we want to put an arrow on the end of it to show that the relationship will continue on. This is not the entire graph, but we are limited to this portion of the graph based on our coordinate plane. So now to answer the question, is this relationship proportional? The answer is yes, and we'll talk more about it in a little while. The reason why this relationship is proportional is because it passes through the point 0, 0, and it is a straight line. Now, if you take a look at the second and third points, when simplified, the ratio will be equivalent. So the constant of proportionality for this graph, also referred to as the slope, is 3 over 1. So that's 3 over 1. So the constant of proportionality for this graph, which is also considered the slope, is 3 over 1. Here's another example. Use the equation y equals 2x plus 1 to sketch a graph on the coordinate plane. So whenever we have these scenarios, we're going to use substitution to help us calculate the value of y by using this table. So I'm going to rewrite this equation, but instead of x, I'm going to replace it with a parentheses because we're going to plug in the values of x into the equation and solve for y. So in the first scenario, the value of x is 0. In the second scenario, the value of x is 1. And in the third, the value of x is 2. 2 times 0 is 0. 0 plus 1 is 1. So the value of y is 1. 2 times 1 is 2 plus 1 is 3. So the value of y is 3. 2 times 2 is 4 plus 1 is 5. Now we can go ahead and rewrite these values as a point. So the first point is at 0, 1. The second is at 1, 3. And the third is at 2, 5. Let's go ahead and plot these points. Here we start on our x-axis at 0, and then we're going to move up to the number 1 on the y-axis. Then we take a look at the number 1 on our x-axis and go up to 3 on the y-axis, then 2, 5. Go ahead and draw a line. And that is the graph of this situation, which is expressed in the table. We'll hold off on deciding whether or not this is proportional until we get to the explanation of proportional relationships from a graph. Now let's talk about it. Proportional relationship from a graph. In order for a relationship to be proportional, considering a graph, there's a few things we must take into consideration. A proportional graph will always, not sometimes, but always go through the origin, 0, 0. A proportional graph will be a straight line. If you list points, which are ordered pairs from a graph, you can create ratios and see if they are constant. Okay, so whatever the ratios are, they should have a constant of proportionality. So now let's go ahead and take what we just learned to decide whether or not this graph is a proportional relationship. So the first thing is it a straight line? Yes, it is. Does the line pass through the origin of 0, 0, which would be located here? Yes, it does. Therefore, this is a proportional relationship. Okay, so it meets all criteria, has to meet all of them, and therefore it would be a proportional relationship. Now this graph looks similar to the second graph that we made. Now let's see, is it a straight line? Yes, it is. Does it pass through the origin of 0, 0? No, it does not. If you notice, the origin is down here, and where it crosses over the y-axis is actually at the point 0, 2. Therefore, this is not a proportional relationship. What about if we're given a set of points? How can we figure out if this set of ordered pairs are proportional? Well, we can create a table or we can graph them. We do not have a coordinate plane right now, so the easiest thing to do is to go ahead and create a table. So we're going to label X and Y, and we're going to start off with the points. So we can do 8, 4, so 8 here and 4, 10 and 5, 5 and 2.5. Let me rewrite that 5. So 5 and 2.5, 12 and 6. So now let's go ahead and take a look at the ratio of y to x. So taking a look at our first set of values, y to x would be 4 to 8. Then we have 5 to 10, 2.5 to 5, and 6 to 12. And then we can go ahead and simplify these ratios. 4 to 8 would be a half. 4 goes into itself once, it goes into 8 twice. 5 to 10 would also be a half. 5 goes into itself once, goes into 10 twice. 2.5 to 5, so $2.50 is half of $5, so that's 1 to 2 as well. And then 6 to 12 is 1 to 2. So here we see that the constant of proportionality is the same for all of these ratios. Therefore, this relationship is proportional. Okay, so whenever you have a list of ordered pairs, you can either plot them on a graph and connect using a line, see if they go through the origin, or you can create a table just like we did here, simplify those ratios of y to x, and see if they are equal. What about from an equation? How do we determine if an equation shows a proportional relationship? Well, we can substitute a 0 in for x and solve for y. If y turns out to be 0, then we know that it does go through the origin and therefore it is a proportional relationship. Let's see what that looks like. So we're going to rewrite the equation, and instead of putting x, I'm going to put a parentheses for our value. So y equals 3 parentheses plus 1. And now in place of x, I'm going to plug in 0. So I have here that y is equal to 3 times 0, which is 0, plus 1. 0 plus 1 is equal to 1. So in this scenario, y is equal to 1. So that point taken into consideration my x, and my y is 0, 1. And that is not the origin. Therefore, this relationship is not proportional. Let's do the same thing for the next one. So y equals 10, and in place of x, I'm going to put a parentheses because I'm going to plug in the number 0. Y is equal to 10 times 0, which is 0. So here again, taking into account my x and my y, I plugged in x as 0, and when I solved it, I got y as 0. So here I have the point 0, 0. This is the location of the origin, so yes, this relationship is proportional. All right, thank you for watching and have a wonderful day.